So today we'll complete a monohybrid cross. Ne? And then the way in which we're going to do it is first by looking at basically the basics of a monohybrid cross. So according to your exam guidelines, about this outline your monohybrid cross, and you want the maximum guy. Phenotype the parents, and then genotype the parents. We're gonna get to that later on. And then the gametes it's abona, and then we Punnett square for the for fertilization. Then banaba okay, phenotype yabona, physical appearance baba almost 1 out of our 4 on a physical appearances, so or baba 2 out of our 4, which is half banal appearances, so and then baba almost 1 out of baba 4 again on the appearances, so and then ufale genotype it's about. So go kwala P1A ne go kwala P1 le F1A ke mark, go kwala meiosis le fertilization ke mark, 2 marks 2 ja I think we just see ne ke sasa marks da go tesa ba ne. So at least we should get these marks for free. So this is the outline. So let's remind ourselves very quickly of certain words before we get into the hybrid monohybrid crosses. So come on, before I go monohybrid cross, let's remind ourselves that from your mother and your father, or receiver the allele. Ne? Let's say, for example, you receive the tall allele from your father, and then here's the tall allele from your father, and then from your mother you receive the short allele. Remember, it represents that if it's recessive, it represents a small letter t. Then we receiver from your, so you are going to have these two variations of a gene. Ne? And basically you'll be homozygous for this gene. These two variations of a gene, which we call alleles, from both your parents. Ne? So we can represent these this information in a cross, right? Good. How? Here of a problem, for example, a tall male, ne? A tall male, monomotor, ne? Who is heterozygous tall, is crossed with a short female. Usually when we don't say she's heterozygous or homozygous, and now it's not like a junjula. And then we tell you tall, the height tall is dominant over short, ne? And they are both represented by the letter T. Ne? We'll choose, so T meaning is dominant and small letter t will be recessive. Ne? So let's see this now. Arbon. Before also over Punnett square, I usually say get the genotype. Ne? Bob, a tall heterozygous male. So the male or tall, ne? And we say tall is dominant again. So that means only capital letter T, ne? And another allele here. But we say that heterozygous, that means he has different another different gene, so he's heterozygous for this trait. So that means agasini le another big letter T, otonale another small letter T, because why? Heterozygous. If in gale homozygous tall, natonale big T, homo meaning the same, homozygous, but that is not the case. Ne? Good. And then baro crossiwale a female who is short. If a female contains just one capital letter T, this allele, that means that female is gonna be tall. So that female are tall. O short. So that means O homozygous short. Why? Because of, if we were to put a T here, a big letter T here, that means that person tlabale tall, because tall is dominant over short. Are we together? Then sharp. Once on the genotype tsa bona re ka boela ko rede ya re ko man wena man o etsa bjang re ka boela ka mara example wa rona. So ra thoma o kwala py ke mark ba yo number way yo tse ke mark tsa mahala ANC ya provide ne. So or phenotype ya hae ke eng ba re a tall male, o ikwala ka botlalo full ka mokgwa o fileng yona contant. ba re o meita leng ba re di betha le mosadi o leng hore o short, so ke short female. Then from there wa bo ba re nyake genotype. Remember rena se re di bethile ka pele genotype ya monna le ya mosadi. Ba le genotype ya monna ke eng genotype genotype ya monna ela o tall, heterozygous tall, and then this one is homozygous. Hebo almost ra fetsa mmaka bobedi wa bona. Then o ya mo meiosis wa ikwala hore o irala meiosis before na le digametes a ikhona le hore o nne le digametes o sena le meiosis. A ke meiosis ke yona e irang digametes ne. So from there o kwala digametes tsa hao, gamete ya ntlha di a separate ne, they are sort independently there, or a shiwe e nngwe gamete ka nna di kwala bjana e tshwene, then e nngwe she, then e nngwe she ne. Remember rule again di be far apart from each other o khona o re bontsha o ka nna bja comma in between them, but di be far away from each other gore re khona o bona hore ke digamete dio tsa a se di ale ne. Good. Then wa kwala fertilization, o kwala fertilization le meiosis ke mark chief wa mahala fela wa kwala after. And think about it, we have parents, we know how they look like, and then banale genotypes ne? We know how they look like because of these genotypes, and then we iralang ka mara bona we irala meiosis ko basadi ke nthweng eo is during gametogenesis, which is your oogenesis. Ko banneng ke eng spermatogenesis. That's basically what meiosis will do in both the male and the female, and then both those processes create the gametes. And then after that school that's what we fertilization ya irahala. Then the next step re bea digametes tsa monna a shidile re bea tsa mosadi. Good. Then ra cross ne, he re ra cross re nyaka go bona hore he e ka fertiliziwa le e, so ho tlhaellang T wa bona. Then the very same capital letter T ne hape he re ka tlisa ka mo ra tlisa le e ka mo ho tlhaellang capital letter T small letter t. Then ra boa hape he e le e di kopana di irang small t, and then he e le e kopana ho iralang small t and another small t. La bona. So e re ke kwale in a way in which it tlo bonala, because mo a re bona le sepe yellow a se color e pila a re kwale ka color e visible. So basically what we were telling you is that if you have these gametes ne, homozygous then heterozygous, we're going to have T, then T, and then T, small letter t, small letter t. Then o feditse ba ke bana ba hao ne. After fertilization ke eng ke F1 generation ya hao o kwala F1A. So for kwaling F1 le P1 ke mark, o kwetse meiosis o kwetse fertilization ke 2 marks, setse o kwetse phenotype ke 3, wa kwala genotype ke 4 ke ba mos o feditse wa bona ke di mark. Then what phenotype wa lebella hore ona le, first things first, ona le e ba ithuba ne, because they have the exact phenotype as the father, genotype as the father. So there will be, that's 2 out of 4. 2 out of 4 ka metse re ka nne re simplify ra re half of them are tall. Ne? And then another half. That's 2, 1, 2 out of 4. That's half of them are short. And then what? What happen? Re nyaka di genotype bjalo. Ne? 1 over 2 happen are big T, small t, and then 1 over 2 king small t, small t. Now, if you feditse cross out, jele di marks tsa 6 wa feta. Mo a ba tshwanna a re tshwanna o senya nako, a re tshwanna o senyetsa nako. Ke yone e fedile bja. Ne? Good. And then remember, later on we create types of dominance. More deal like a complete dominance effect. Dominance. Ne? What is complete dominance? Meaning that if we cross two of these parents, ne? One of their phenotypes will be expressed in the offspring. Meaning, here crossa monna o motelle le mosadi o mo short. Either one o tlo ba short or o tlo ba taller. Ha ona le between, ha ona re tall and short. Either over tall or over short. Re ka crossa monna o mo black le mosadi o mo white. Either one o tlo ba black or o tlo ba white. Ha ona re o in between ke le color. I think that day. Ne? That's what we call complete dominance. So, I read example tse ding hape ne? Re tla tla go di Mendel laws ka wa ra ka tsona re tlo di betha ka speed ka tshepilwe. Then nka tsa problem e one mo a re ke tse problem e one so ha re betha so ne ke tsa problem e one ba utlwele tabeng e khula shiba. Now this is more realistic. In humans, dark hair, which is represented by capital letter D, is dominant over blonde hair. So already when we equal oh, that means capital letter D is dominant. And it represents dark hair. Oh, why? Would be I think information now again. And then small letter D is recessive. And it represents blonde. By color, right? Recessive. So if a heterozygous dark-haired man, heterozygous means the alleles will be different. You over different. You over D and then it has to be D so, because that is homozygous, but because bariki heterozygous, so also need to be different. You over small letter D. If mono was small letter or big letter small letter D and O na le dark hair, o crossiwa against mosadi wa blonde hair. Because blonde hair is recessive. I will not the capital letter D. So you have two small letter D's. Already is another genotype. But now, it's over the question. What would the probability be that the son would have dark hair or channel le papa high? Now, what is the probability? Remember, probability is in the form of diffraction. Answer the diffraction. If value percentage, we have the percentage. If value ratio, we have the ratio. So here's the case. Rato P1 generation. Renyagadi phenotype, physical appearance. Ling le genotype. So ratomaka phenotype ya monna. Monna la ba re ngona le dark hair. So ratom re dark. We kwala ka mkhobo o fileng yona. Head man. Ne? O crossiwa leng le a blonde head woman or wife, whichever one comes first. Ne? Good. Then tabe batho modimo ke mmako pele mmako already o feditse ra ja mo re je. Then genotype re editse ba re monna o heterozygous dominant. So heterozygous ashile o mo crosser le a blonde woman who's homozygous recessive. Oh, tabela shile banna ke di marks. Re jela mo. Then obviously we have meiosis in both of them. After meiosis answer the gametes. after meiosis inside the gametes tsa hao wa dira shedile ya ntlha she gamete ya bobedi she gamete a shile and then tsa mosadi di gamete a shidi and then tsa mosadi ke tse two di gamete a shidile ta ba shiwe bana ba papa re ja di max mahala bona awa more gel. Then we have fertilization. Agrilo ho kwala di gametes le fertilization ke mark o jile setse o ja bjalo ne then re draw Punnett square nna ke rata Punnett square a ke rate the other cross ne good then we draw Punnett square how with the gametes actually RDB the gametes gametes are such that ashid big D small d yes let's start small d small d yeah? All right then right cross big D and small d ashid then big D and another small d then small d and then small d again ashi onale bana ba hao remember a ke your offspring. These are possible offspring ne then what ne or f1 after kwala f1 and notice o grile makomo agro ka p1 what f1 ke mark bona mark sa mahala ra itela rena ra tsamaya then more first filial generation f1 offspring ne le bona bana le phenotype ne and le bona bana le genotype mara ba o file instruction or o represent phenotype le genotype bjang re boele ko question e re represent probability that means ka fraction bana ba papa re boela ko tabeng e kholo ashi re re phenotype ya 1 2 ne dia tshwana so that means they have dark hair they are homozygous exactly like the father they are they are heterozygous meaning they have two different alleles ne heterozygous dominant for dark hair okay raibona ashi so out of baba kai 2 out of 4 could be 1 2 3 and 4 2 out of 4 but 2 out of 4 can represent the essay as 1 over 2 right simplify always simplify the fraction it's a half ne 1 over 2 if you don't understand what you're writing 2 over 4 is the same as 1 over 2 I get that's fine good then buying they are dark remember give phenotype physical appearance manale dark hair they're dark haired ne? And then 1 2 bona aba dark haired but blonde so it's 2 over 4 which is the same as 1 over 2 are blonde haired and then our face genotype is the same 1 over 2 ne give big D small d and then 1 over 2 king big D and not big D small d le small d like what kita barena then our fetsa araba question bare what would the probability be akho we le cross out feditse why when o ka se expect to nna ke nyake answer tshwantse mpotse gore answer ke so what would the probability be that the son will have dark hair like his father probability ya dark hair ke eng wa lebella o ya mo probability of having dark hair ya go phenotype akere dark hair ke phenotype oh ashi probability for dark hair son is 1 over 2 ne? That is your probability na pele o bolele question e la batho nga ba re feditse di jesi di marks tsa mahala to ja la bona Rigel. Ne? So that is that is how to solve those type of questions. Ne? Good. Arnyak engwe ka pele re bone bone. Ar lebelleng number ai e re ke tlohele. Ar lebelleng number 4. Alright, we'll decide ourselves. Tla. Bar taba shutse kholo bjana. In roses, long stem is dominant over short stem. Okay? Why you got that? So long is dominant over short. Okay, sharp. A homozygous. That means the alleles are the same. Long stem plant is crossed with a homozygous short stem plant. What percentage of the resulting rose plants will have long stems? Ne? Okay? For example, let's give ourselves the allele. It is represented by the letter L. Ne? L for dominant and then small letter L for recessive. That means it's for short. Ne? And short is recessive. This is for short. Small letter L for short and big letter L for long. Good. Then, Ratom, P1. Phenotype, then genotype. Ne? Phenotype ile genotype. Then phenotype ya bon. Baleng a homozygous long stem plant. Homozygous, ne? They must be the same. Ne? Again, for long, we said it's capital letter L. For short, it's small letter L. It's crossed with a homozygous short stem. And short stem is small letter L. So we're going to have two small letter L's. Ne? That's the genotype. Sorry. Excuse me there. King is genotype. Then the phenotype. Barring long. We call it stem plant is crossed with a short stemmed plant. Okay, the marks out 2 marks already. Oh, Ravai. Then meiosis it virahala a very nality gametes. Gametes are how? Big L, big L, then a small l, then a small l. My work is rough. Then after this, fertilization will take place. Fertilization takes place and then we draw Punnett square for fertilization. We Punnett square like a speed. Arbolai Punnett square. Then ratom. Gametes. Tomorrow draw the gametes big L, small l, small l. Then our drawing the cross. Big L, small l, across. And then big L, small l, and then big L, small l. This one is what it is. But what percentage of the resultant rose plants will have long stems? Oh, Rako F1 generation about Kali. F1 generation, we say phenotype and then genotype billion. And then for array level, let's see array number 1. All of them, all of them are long stemmed plants. So that means for the phenotype, you're gonna say vale represent the percentage. What percentage? 100%. Then 100% of them will be heterozygous LL. That is how we answer that question. They are all heterozygous. Like what? 3. So there's really nothing to it when we draw Punnett squares. Ratios. Ratios. Then I'm going to show you one for ratios. Number 3. I'll say number 3. Number 3 reads as follows. A heterozygous tall pea plant is crossed with a short pea plant. What are the expected genotypic and phenotypic ratios? Now, the answer is no longer in the form of probability, which is your, kind of what you call them, in the form of the fractions. It's no longer in the form of percentage. Now it's in ratios. Arebo. But Rato. P1. First parent generation. Revela phenotype. Le genotype. Then, barring, what are the phenotypes? A heterozygous tall pea plant is crossed with a short pea plant. Here. So, barring are using the letter. This time let's use S. S will be for tall, and then small letter s will be for short. But a heterozygous tall pea plant, for it to be tall, it must have a dominant allele, which is capital letter S. But because it is heterozygous, it must have a different allele, which is the short allele. And then it's crossed with a short pea plant. So you have two small s's. Here you have big S, small s, then small s, small s. And then likewise, meiosis, then a form of the gametes. Then a form of the gametes, big S, gamete, small s, gamete, then small s, and small s. You don't have to do these lines that I'm doing, as long as really far apart from each other, differentiate. Good. Then king, after we do fertilization. Remember, get the max especially these ones. Get the max maha. Free max. Fertilization, that means you're gonna draw your nice Punnett square. Ashi. Done. And then gametes. The gametes are in again for always big S, small s. Then for the female, small s, small s. Then combine. Our offspring. This will be crossed with this one, that's big S, small s, and this one, big S, small s, and this one, small s, and then small s, small s. Then after that, you see, now that we have our offspring, we can therefore write the first filial generation will be such that we have our phenotype and genotype. Good. Then we're gonna say phenotype yabonaki. Remember, the big S represents a tall pea plant, and the short pea plant is represented by small s, the phenotype. So let's count them. 1, because it has this one. 2 because of this capital letter S. That's the only place we see capital letter S. So 2 out of 4. But remember, we're representing this in terms of ratios. So 2 will be tall P plant is 2. Remember, is 2. 2 of them, that's 1, 2 will have short P plants. So your phenotypic ratio is what? Is 2 is to 2, which is the same as 1 is to 1. You must simplify your ratios as well. When we move to the genotypic ratio, it's actually the same. We'll have 2 of them having this genotype, and then is 2 of them having this genotype, small s. So that means the genotypic ratio is actually 1 is to 1 as well. That's how you answer this question. Remember, all the monohybrid crosses, the 3 monohybrid crosses, it's an complete dominance. We'll get to do complete dominance and Mendel's laws in the next video. If should you have any questions, did go ahead and more comment section, and then get the Araba in the next video. So when I just practice using number 2 and then and number 5, that's the one AC can resolve.